Let's practice the washer method. In this problem, we're being asked to find the volume of the region that's bounded by y equals x squared, y equals square root of x, and is being revolved around the x-axis. To start, I'm going to go ahead and make a sketch to understand what I'm actually looking at here. Great, so we have our region sketched. I've gone ahead and shaded it in. The only thing left to do is go ahead and find the intersection points of those two functions. Those will serve as the bounds on our integral. To do that, we'll go ahead and set both equations equal to each other. Then we'll square both sides. Moving our terms to one side and factoring out an x, what we end up with is x being equal to either 0 or 1. Okay, now that we know the boundary points, let's visualize our revolution. So we're taking this region, we're rotating it around the x-axis. What I'm going to do is I'm going to draw my clone of this shape that would have gotten revolved around this way. That way I have a better idea of the overall shape that's being produced. So my clone looks something like this. And one slice of my revolution looks like this. So I took this piece, I rotated it around to make a washer where we see this inner part here, all of this space has to be removed because that's not part of the shaded region there, okay? So we need to use a washer because there is space between the region we want to rotate and the axis of rotation. So if this region was not there, we would be fine with a disk instead of a washer. Setting up our integral, we use the area formula for a washer, which is pi big radius squared minus small radius squared. Our outer radius of the bigger radius is going to be the root x because this full length from our x-axis all the way up to the top would be just the height of the top curve, root x. And our inner radius, or little r, is just going to be x squared because this little segment right here from the x-axis upward is just the height of this curve, which is the parabola x squared. We are going to be adding these washers left to right in the same fashion, right? So if we're rotating this like this, we have one slice there. You need to do this a bunch of times to get all of the washers and then add them up across the x dimension. So our integral should be, with respect to x, we should have a dx here. And because we're integrating with respect to x, our bounds for the integral should be 0 to 1, just as we had found earlier. And there you have it. The volume of our bounded region revolved around the x-axis would be equivalent to this integral. I'm not going to solve this integral all the way out, but if you do, let me know in the comments down below what you got.